The most common early use of input and output that you're going to see in Java is dealing with files. It's not something that necessarily you're going to use all the time. There's certain types of applications you use this quite a bit. There's other types of applications you won't do it all that much. So like batch jobs, you'll deal with files quite a bit. In websites, probably not so much. And even within that, there's going to be particular frameworks and tools that you'll use where you won't necessarily even deal directly with files all that much. But regardless of all that, it's really important to understand the fundamentals of how Java interacts with the files. Because you got to remember that Java is a virtual language. It's living on top of the actual implementation of an operating system, another thing that's going on in the solution. Java's not dealing directly with the computer, the processor, so much as it is dealing with interpretation. So since Java is built as this dynamic language that's built on top of a bunch of layers, it's actually intentionally a layer removed from files. So files in an operating system, files on a computer, are a great way to store data before or after a program exists. They exist before the program's run. When I write or read data from that file, it exists after the program ends. So if I have the graphical user interface I had before, you probably noticed, you type in stuff, you save stuff, it actually just disappears when you stop running the program. You go run it again, you got to type all of the same stuff in all over again. Where with a file, it can persist afterwards. It lives as long as that medium, that device works. You know, that the hard drive, if you will, that's out there and it's available. So within Java, since it's a virtual machine, we have to have a way of represent that file, which is a very real thing on that computer mechanism. We're not dealing with it directly, we're not dealing with it as part of the language itself in Java, but we're dealing with it as part of the whole structure of how we would deal with the file, kind of as a person would. So as a person, we can deal with a file, we can read a file, we can write files, and we can manage them. That's the main things we do with them. You know, we go in your Internet Explorer or whatever the equivalent is on whatever machine you're using. You double-click a file, you open it up, and you read it. Or you hit save, you know, Microsoft Word or Notepad or Excel or whatever application, it writes to a file. You're actually doing that through a helper application. That's what we're going to be building, is these helper applications. And those also can do things like creating directories, moving files, copying files, deleting files, all that sort of stuff. And so Java, we can do all those things. But as I said, the language itself doesn't have built-in commands directly. It has helpers that we need to be able to do these things, because we want Java to be write once, run anywhere. So I don't want to tie into the language the rules by how do I write to Windows versus how do I write to Mac versus how do I write to Unix. I want those things to be a little bit more flexible, and I allow the Java virtual machine to dictate those. So in Java, we have to have a representation for a file, and that is the file class out of the library java.io. That's the package that's represented. And so it's important to understand that this file class represents a file, or possibly a directory. And it's created as a representation of said file. I can use a string to define the file name. I can define that file relative to a different file. I can use a URI. That's the file : / approach to things that you might see, kind of like a URL, but URI is for local files there. But you have to understand, this is not the actual file. In Java, I'm just representing something that will represent the file. So it's like if I write your phone number down in my address book, that's not you. I don't talk to you. That's my representation of how do I go and access you. How do I call you? That representation might be accurate, it might not. You might not actually have that phone number. You could give me a fake phone number out there. But it is my representation for how I plan to talk to you. That file, likewise, might exist or not exist. It might be a file you're about to create. It might be a file that's been out there a long time. It might be a file that never is or will exist. But the file mechanisms allows us to create that file if we need it. We can create that placeholder. So understand, when I have a file object, I'm not actually reading or writing from that. It's just a representation of something that I could read or write to. So when I'm working with the file object, I can do something like this. We can see in the code here. I create a file object. So I have a variable, which is a file. And I create a new file object, and then I can give it a string, which is to an absolute location. We'll talk about absolute versus relative here, but C/temp/test/myfile. A couple things to note. The double slash here is because in Java the slash character is an escape character. So if you actually want to put a // into a file, then you have to put two of them inside of there. That's why there's two of them. But you'll see that quite a bit in Java. But this is an absolute location, temp test my file, which assumes on the operating system you have a C drive, you have a temp folder, you have a test folder, and then you can put my file inside of that. That's not super useful sending it to somebody else's computer, because what if I don't have a temp? What if I don't have a test? Then this file certainly doesn't exist. But it works for now. It just shows you the capability. We'll talk about relative versus absolute file positioning as we go. One of the things I can do with a file then is I can actually ask, does this thing actually exist? If the file exists, then I can tell you the file exists. Otherwise, I can do a couple different things. If it's a directory, I can say make directory without an S or with an S. So if I throw the S inside of there, it will create all of these as a directory. Now, the trick is, Java does not differentiate what's a directory, what's a path name. So if I ran this line of code, say mkdirs, it would create a temp file folder if needed. It would create a test folder if needed, and then it would also create a folder called myfile.txt. The fact that there's .text inside of there doesn't mean anything with Java. You can have a directory named .text. There's nothing wrong with that. Or the alternative is you can create a file which then assumes temp already exists, test already exists, and then it'll create a file, myfile.txt, that's empty, has nothing in it, but it'll hold that file name. It'll create it on that. So I can do one or the other of these, not both, but I just wanted to show you examples of that. Here's an example here where you can actually create a directory. Here's a directory path C/temp/Apache Tomcat 6.0.20. It's kind of an old version of Tomcat. And from that directory, I can actually do things like tell me all the files that are in this directory. So I have a for loop inside of here, which will, this dir directory .list files returns an array of files, and I can loop through each one of those, and I can tell you what the name of the files is. They might be further directories underneath there, and so I can actually walk through a directory path. I can actually ask, is it a directory? That's a method out there in the file object as well. Again, none of this assumes this stuff exists. dir.list files could return back nothing. So it's important to understand relative versus absolute directory. Like in most operating systems, in Java, the dot as a directory name is the current directory. It's the place I currently am stored, currently am running. In NetBeans, that's going to be the default of your project folder. If your project name is Tony123, you're going to run your program in the folder Tony123, wherever that's located on your machine. Typically, my programs, my files /netbeans/Tony123. If I want to look at the folder one above, it's .. If I want to look at the folder down below, it's the name of the folder. And so I can go to all that relative addressing, all that relative pathing that I would normally do inside of the Java application. I'm sorry, the Windows application going forward. But as I said, the Java file object is not the contents. I cannot read any data from it. I cannot write any data to it. All I can do is know where it is, if it exists, and maybe do a little bit of management over the top of it. Though even though there's a little bit of risk there. I can't delete a file that doesn't exist, for instance. It won't let me do that. But it will not let me access the data in that file. I need other helpers for that. We're going to talk about those in a little bit. But it's really important to understand the role of the file. The file is there to represent like an address book entry. It's not the thing. It's not the house. It's not the business. It's just the address of that thing. The business could move. The house could burn down. Could have not been built yet. But it gives me a path to be able to go and work with these files that we will go from there. So we'll continue on, but that's a start to one thing in Java, which is the file and how I can access some of this information.